And then let me share this. Maybe we can look at it a little together. So, okay, we got like a Rusty runner here.
Yeah,
doing all
exactly.
these things. Takes a lot of boilerplate. And okay, and then it invokes gen, which I don't know what that is, but I
Like
guess it's
the gen decal, and there
yeah,
it
okay.
basically iterates the items in HIR and generates like Mir Formality syntax for each. And
This is
currently
awesome.
only the local crate, so it doesn't like respect any other declarations yet.
See, we're throwing in some unknown items for extern crates and things. It's got a static. I was going to ask whether it includes types, but maybe the example doesn't have any types that are interesting.
Yeah, it generates like ADT declarations, if you mean that.
That is what I mean, yeah. What's this MF apply?
It's to apply the user type, like the user type function to convert the like one syntax to the other.
Oh, okay.
Like the user type syntax, because it might be easier to read, I guess.
Yeah, no, I think that makes sense. You should. In fact, I plan to modify the declarations to just take user types directly and not, so you don't even need this. This would just be what you would write.
Yeah.
But I'm wondering, normally, I guess I would expect this to be in a term declaration. Like just wrap this in term, or wrap this actually.
Actually, I have also one like function which generates like the lat vertex lat syntax, and there it's like wrapped in term.
Mm-hmm. Because then you wouldn't need this. I never even heard of this MF apply, but I guess that's some internal helper thing, meta function apply or something.
I think
Yeah,
it's
okay.
otherwise like the meta function name is interpreted as like part of the grammar.
Right. Yeah, but if you put it in term, it would
Yeah.
apply, but yeah, okay. Interesting. And what were you saying about generating the redx let?
Yeah, I mean there's I can push this stuff, or I mean like if you specify minus lat, it generates the
Okay.
Generates it differently inside a vertex lat.
This looks really cool. I don't know. I guess this kind of looks like exactly what I was hoping to get. Have you tried to run these tests and see what happens?
Yeah, I mean, I already found some issues with like for example, the MF apply thing. So there's like still some things which don't work correctly yet. But yeah, like today I was generating some example code for the normalization issue.
Mm-hmm.
Yeah, I mean it worked after some fixes.
I guess you have to remove the unused items and so forth.
Yeah. Also, like one of the main issues right now, I think, is like the lifetimes in MIR, because I'm not sure. Like right now, it's all fresh variables, but I guess like like for the type checking, we want the like unified version where there is like not one variable for like each lifetime. So like basically all checking.
Actually, I don't think so. I mean, that's at least how the borrow checker works now, is that it sort of figures everything out, so it doesn't have any.
Okay. But then like the question is whether we re-implement like all of the borrow checker right now in Mir Formality, or we like until we have that, whether we can leverage like what the compiler does right now.
But so what I would expect is the bound. I think we want to do the rewrite you're doing now, and then just implement. This is just the same code, copy and paste it. I guess it's pretty simple. I feel like it was more complex than this. Is that all it does? It's nice. we could expose. I'm not sure what you mean by leverage, I guess, or what you expect to leverage.
I
But
mean, like right now, the type check and MIR, like as it is implemented in the formality, it expects like lifetimes to be equal between the local declarations and like a ref R value, for example, I think. And this is not the case right now because there wasn't like any borrow checker who like inferred the lifetimes to be equal, or
I don't think it should. Like, I think what should happen is that it should generate constraints that make them equal, essentially. Maybe it does, because the way we wrote it, though. But okay. So it seems like maybe what we have to do next is just work on the borrow checker side. Kind of
right,
push this
yeah.
example through and make it work. I mean, it's already great to have, like, honestly, you know, just writing this was like sufficiently time consuming that I didn't want to get around to it, you know, even though it's such a simple little bit of code. But I guess I see we have some things like unknown R value here and so on. What's missing? Is there a little list of like the missing things from?
To make this a specific example compile.
Yeah, or just like you must be generating these in certain cases, right? So that's kind of a burn list of stuff we need to handle eventually. Yeah, this is cute. Question mark 0. I don't know, maybe there's not that much to say except we should just use it and see what happens. I thought we would spend more time, but it seems like you made more progress than expected. I guess the thing is, we should probably merge it into the Mir Formality repo, I think.
Yeah, sure.
Why not?
Other thing that we could do is add the like unknown stuff to the grammar for now, so we can just ignore that, or I mean, don't even generate it. I'm not sure what is better.
I think we should add it to the grammar, and then we just have to extend the type checker to handle it. I'm not sure what that piece of unknown stuff was, but
I mean, for example, there's the aggregate R values, I think, of Mir.
We don't have those in the grammar yet.
Yeah.
Okay.
And also a lot of, and I'm not sure whether we need to extend the like handling of constants in the formality, because right now it's only numbers, right?
Oh, that we definitely have to do sooner or later. Yeah. Yeah, right now it's pretty limited. That's neat. Well, what should we do today, right now? That's the question.
We could also look at normalization issue.
Which issue?
Like the making normalization or normalize to inductive.
Making it injective?
Inductive instead of co-inductive.
Oh, inductive. Uh-huh. Oh yeah, we could do that. That would be relatively easy.
I tried to reproduce it today, but I wasn't able to.
That's a good one. I like that. Let's do that. It's kind of self-contained. Let me pull up the code. I'm wondering, did anybody, so I had those various PRs open, and I don't know if anyone ever had a chance to look at them, if any of you did, I guess. It's fine if not. I'm just trying to decide what's the most effective way to get more of a reviewing culture here and less of a Nico pushes code culture. I'm guessing no, or I guess what I can't distinguish is, did anyone here like look at the PRs and just not have anything to say, or did you never just not look at them at all, or not realize I had put them up? Santiago wrote, I didn't review anything. Yeah, that's fine. Didn't expect.
So I looked at the code, like briefly scanned it, but I just found like some typos and everything else looked good, I guess.
Yeah, okay. Cool. I think I'll start to merge them, but I'll just keep doing that same habit. Feel free to, if you don't remember, I don't recall if you left a comment or not, Dominic, but feel free to leave one saying check plus or something. That's always good. So, all right, we were going to look at the normalized to inductive thing. So let me explain the problem for those who aren't following, and so that we can make a test. So I have this example, which I don't know, maybe you said you tried to reproduce it and weren't able to, Dominic, but the idea would be if you had a foo item and a bar item and you direct them to one another, so that foo item expands to bar item and bar item expands to foo item, and then you try to prove it equal to something, well, that hopefully won't work, but with the way the crate solver is today, I think it should work, because you should be able to normalize foo will essentially, oops, there's a typo there. It will, that will normalize to bar, which will normalize to foo, which will create a cycle. And since right now we consider all cycles acceptable, that's a problem. But, okay, here, cool. However, we don't want that. But then again, maybe I'm wrong and it's not proving. So let's see why it's not proving. Either because this test isn't right or because there's some other reason that I don't know. So let me pull up the Xcode or whatever this browser is that I use, or code editor, VS Code. I think it's this one. Yeah. So we'll make a test. All right, let's see. So we got this program, which translates to, yeah, I think here, I don't think you need this MF apply. A little simpler. We got trait decal foo is trait foo of self, where nothing, foo item is this, okay, trait decal bar, bar item, okay, that looks good. Trait impl for foo. Oh, side note, I usually like doing it like this. So it's a little easier to compare them against one another. Although I guess it does make it harder to see the overall Rust program. So this is an impl for foo applied to unit, where foo item is this as bar, bar item, okay. So there's, I think these impls aren't quite right. In particular, this one doesn't look quite right. It should be this. It should
All
be
right,
this.
I see the my mistake. There's
Yeah, but this is bar. It's copy and paste error basically. Bar. Foo. Foo. That's, I want this save. Save. Or it will save, but I want it to format. Format, you goofball. This is the annoying thing about the racket mode is that I don't know if you all use VS Code, but it has this problem sometimes where it's like it works great, and then it just doesn't work at all for a while until it decides to do so again.
also, I think there is a like hashtag missing in the first line.
Which first line? Like up here?
Yeah.
Oh, maybe that's why it's not working. Okay. So now we should say, we want to show that we cannot prove that for all t, this normalizes to t. Okay, sounds good. The other way to do it, I sort of prefer this these days, which is to say, not sure if that's the right function actually, but maybe it can prove call. That's right. Basically, this returns a true or false value. There we go. And instead of encapsulating the test equals, and it's mostly because I get a better line number out when you, but take create decals. You get a better line number out when the test doesn't work. But for that, the nice thing is you don't need to create the environment. We just take in directly the create decals and the create ID. Do we need size or the lib core? I guess we don't. Okay. All right, let's try it. Okay. Something's not matching up correctly on line 10. Module test, am I missing an extra parenthesis? Yes. I think we could probably also run a test instead of making it a for all. We could just put some specific type in there too. But illegal use of syntax, yes, okay. This needs to be in a term because that's a meta function. Okay, we're getting true, but we got expected false. So yeah, there is a bug, definitely. Don't seem to need that, and we don't know if we need this. Okay. I don't always trust these like unused annotations. They've been wrong for me before. Okay. So add test case that demonstrates the problem. Currently failing. So what did I say we should do to fix it? I said we can, oh, right. Right. So the logic solver has this idea when it applies a given clause it takes this argument that's currently either, it's called prove/co-inductive, and it's either plus or it's minus. And if it's plus, we're allowed to treat it like a co-inductive predicate. And if it's minus, we're not. And essentially that means is a cycle true or not? And so what we say right now is that for all predicates in which we kind of got them from the user, all user predicates are plus, but everything we take out of the environment, like if we use a where clause to prove it, it's minus. And that's because the idea of the environment is that essentially all those facts came from the outside. So if we were to depend on something in the environment, which is only true because of something we proved independently, then that creates a kind of opportunity to have these cycles. We want basically in that case, our caller said, if you can prove X, then Y is true. And they should have been able to prove it for themselves. It's kind of the intuition. But what I want to do, and we want to change this, so this is not hard-coded to plus, but so that it kind of depends on what kind of predicate we have. And actually, before we fix this, I'm going to merge one of these PRs because I want to base it on the work in that PR. Now, and I see you left a few suggestions. I'll just commit that. Because I added some concepts that I'd rather not have to rebase over. So let me just pull that in. Okay, so right now we've got, right, so we still have in this branch, we have this extra clause. This is the one I wanted. We kind of have a plus if it's a predicate that we got from goals, or we have this idea of a built-in predicate, or we've got the minus when we came from the hypothesis. And so I want to do something a little more sensitive here, where we look at this predicate and we decide, well, which one is it? Is it a co-inductive one or not? And then we can say normalizes to is not co-inductive, and it should solve the problem. And the thing I was observing in this issue is that we already have a bunch of these little, like the logic solver doesn't actually know the syntax of predicates. It just treats them like an opaque term. So it already has these functions that it can call to ask questions like, is this a predicate even? Because it doesn't know what the grammar for a predicate is. And is it a built-in one? And is it a relation we have down here, which is when you have like A subtype of B. And I was thinking we could merge all these little Boolean functions into one function that said, categorize this goal into one of various categories. And the categories would be like predicate, built-in predicate, relation, or other, basically. Like, so that's what I wanted to do as a refactoring, and then we can change it. So right now, these are the grammar of goals at the logic level. A goal is either an atomic goal, which is like a predicate or a relation, or it's one of these built-in connectives, like all, any, implies, quantifier. But if you go to predicate, you just get any term. That's why we have to have this classifier. So we can add in something like goal classification is user predicate. For now, we'll just add in different categories: built-in predicate, built-in relation, or connective, or like built-in, yeah, I guess built-in goal. I'll just put a quick comment. Since the logic layer doesn't know the syntax of predicates, it has to use the hook callback to get this classification. This makes sense so far?
Yes.
Okay. So then where is this hook predicate? So the formality logic hook is a little weird. It's a little racket struct with a bunch of lambdas in it. You can see there's one for is predicate, one for is built-in predicate, and one for relation. We're going to just replace them all with categorize goal. And we'll get rid of this, get rid of this. And this will say, given a goal, returns a goal slash categorization based on the refined grammar. And then, so when we delete all that stuff, we have to delete. So let's repurpose this function. But we have these wrapper functions, which these are meta functions, so they're like regex functions. And all they do is sorry, let me just write this code and then I'll explain it. Let's call this, let's give this a name that's more descriptive. Okay, so what does this do? This is kind of wicked black magic. This where error, so env hook extracts the hook, which is an opaque racket object. This where error extracts that opaque racket object. It uses the term because it's saying this could be any value. I don't know what it is, and it's called hook. Then we call this comma brings us out of regex, out of like logic land and into racket land. We call the accessor, which pulls out the field from the struct. We call that categorize goal function. We call that function with the actual goal. So this just kind of does the little trick to categorize the goal according to the grammar defined by the upper layers. And then we don't need is built-in predicate anymore. And we don't need is relation anymore because all of these things are going to be just based on categorizations. And really, we don't need is atomic goal either. I don't know, where do we even use that? I guess we'll find out. Now we have to remove that other stuff. Annoyingly, this isn't Rust, so it's not sufficiently well typed for the compiler to take us from place to place. So we'll have to do some searching. But let's start with the logic test, or let's start by removing the code in the logic layer that was invoking is predicate. Well, first of all, I'm going to remove this. So this is the list of exports from the module. So I'm removing all the functions I deleted, adding this one that I added that apparently doesn't exist because I gave it the wrong name. And now I'm going to go into the code. So this function is calling is predicate instead. I mean, I guess we could actually, maybe we should add those functions back as convenience functions. That might actually be an okay thing to do. So we could add a function like this. Is predicate, we'll take the goal, return Boolean. And all it has to do is call, it's instead of defining it by this hook, we're just going to say where the built-in predicate, or where we're going to call categorize goal and just check that it gave back a user predicate. That was what we called it, right? Yeah, user predicate. And I think it's also true for built-in predicates, for better or worse. Maybe we'll rename it to is user predicate. Yeah, I think there's a reason it's meant to be that way. So we'll make both of these true, and then everything else is false. And then we can add a similar one for is relation. We don't need two clauses. Let's just keep those two and see if we need the rest. I don't know. We might. But so now that we left that helper function in, this call is fine. It's just going to call that helper function. This is the hook code we were just editing. And this is the solver code. I think I'd like to change this a little bit because here we're doing these more like multi-layer tests. I think I'd rather say where user predicate categorize goal and predicate. So now we're testing. Before we said, is it a predicate and not a built-in predicate? Now we're able to be more selective with one statement for just the thing we wanted. This one, so this checks for a cycle in the, this basically says if, sorry, not for a cycle. This checks to see if that user predicate is defined in the hypotheses. And actually, I think we want is predicate here because the built-in predicates are just predicates that we're supplying the clauses for, essentially. So they can be just like any other thing. They can appear in the hypotheses, and that's okay. Same here. This is for co-inductive cycles. It's fine. Good. So far, so good. The main thing we have to change is here. So this is the testing code for Lambda. It's what actually instantiates that hook. And, or there are several cases, but this is like the simplest one that just tests the logic layer in isolation, right? And so right now it has this, it calls logic is predicate, which is defined down here. And so we need to change this to, first of all, these are the three functions that we just removed. We need to get rid of two of them and redefine one of them as logic categorize goal. So I usually use this convention of putting the layer with a colon when it's like, this is the version of that hook that applies at that layer. But this is goal, what did I call it? Categorization. So if it's a built-in goal, then the first thing we'll return is built-in. Is that what I called it? Yeah, built-in goal. And then if, so this says if it looks like this, one parameter equals another, that's a relation. So let's return what did I say? Built-in relation. And then when we're testing the logic, we just define our predicates to be things like single variables or whatever. And we don't have any built-in predicates. So everything else is user predicate. And then I can get rid of this stuff. That's it.
Question, like, maybe could you just really briefly repeat why we need the whole hook system, or what's like the?
Yeah. So the idea is I want to have these layers so that the logic layer can be tested and described and understood independently from the other layers, and similarly the type layer and the decal layer. The problem is the logic layer needs a way to find out things like what are the rules that we have derived from the user's declarations. right? So if you wrote impl foo for bar, that translates into a rule that says like, is implemented of the trait foo applied to the type bar is correct if the where clauses hold, things like that. And we need a way to get those rules in to the bottommost layer. And in particular, there's an infinite set of such rules, it turns out, because so you can't kind of produce a total, like initially I thought we take the Rust program, we would read the declarations and convert it to a set of rules, and then we'd hand the rules over to the logic layer as this like independent entity. But it actually doesn't work like that because there's an infinite set of rules. So we could never generate all the rules the logic layer might need. So instead, we bundle up the thing, like the source, into the hook where it's opaque to the logic layer. And we give the hook to the logic layer, and then the logic layer can on demand pull the rules that it needs as it needs them, because it's never going, well, hopefully it won't need all the rules in that infinite set. And the reason there's an infinite set is stuff like auto traits and I'm trying to remember what else. Just our annoyingly rich family of types, which are also infinite. So like, for just the simplest rule is a tuple of arbitrary arity is copy, right? And at least today, we don't have a right to write one impl that matches against a tuple, no matter how many elements are in the tuple. So there's kind of an infinite set of copy impls for tuples as they get bigger and bigger and bigger. And the hook manages that. Does that make sense?
Yeah, that makes sense. Thanks.
Yeah. So that was pretty easy. So then I think there's another hook here. Yeah. So we also have a place where we test the type layer in isolation. So we have this tie is predicate. This needs to become tie categorize goal. Which is kind of the same function. Not exactly the same, but pretty similar. Well, the big difference is actually the tie layer does define the grammar of predicates, so we can just use that. Hold on. So a relation is a built-in relation. I see. That's kind of an interesting thing. Well, it's okay. And the tie layer does not define any built-in predicates. It defines what the set of predicates are, but it doesn't understand that some of them are built in right now. That's okay. Don't think it needs to. So it's just going to return these things. But then we have to modify the code that's using tie is predicate. Notably, this is the code for testing the hold on, I'm doing this wrong. Yeah, so this is the code that generates the type level hook. And so it just wants to say tie categorize goal. Then I guess, annoyingly, we're going to need this is the decal layer hook, same code, but this is the actual one that we really use when we're not doing small unit tests of a particular layer. And so it's going to need its own decal categorize goal function, I think. Because it was previously defining the built-in predicates, and it needs to do that. So wherever I defined this function here, this should be decal categorize goal. And we'll just we'll just screen out the predicates that we know to be built in, and then we'll delegate the rest to tie categorize goal. Should work, except we probably have to import wherever tie categorize goal comes from. Source tie hook. So then I think we're all set, except that for some reason, I deleted some of those helper functions. And I don't really remember why. I just felt like it. Like we used to have is atomic goal here, and we no longer do. I think I'm going to add it back in because it's basically just going to be or is relation and goal, or no, any, I think I called it. Or is predicate. Is that actually a helper function? Yes. Okay. And I think there might have been an is built-in goal. No, or if there was, we're not using it. Let's look at our diff. No, we did have so we replaced built-in predicate with tie categorized goal. That looks good. We removed these two helpers, added categorized goal from the definition of logic hook or decal hook. We're invoking categorized goal instead of these more complex combinations of booleans. We added these 4 classifications. In defining the logic hook, this looks wrong. This shouldn't be there anymore. What is that? Oh, that's just the list of we did have an is built-in predicate, or is built-in predicate. Okay. This is the list of exported things. We still want to export is atomic goal. That's okay. We removed these 3 things from the hook. Good. We defined categorized goal in some way to call the hook function. We defined is predicate. We defined is relation and is atomic. We removed is built-in predicate, but I think we're no longer calling that function because we're just using, it only had 1 caller, and we removed that too. We replaced these 3 things in the defining the hook with calling categorized goal. We defined the logic layer version of that. Okay. We deleted this code we don't need. Defined the type layer version. Oh, okay. This is surely not going to work, but let's try. I mean, I still don't expect this to actually fix the bug. This is like the refactoring before we can fix the bug. But it'll hopefully not die in some new annoying way. Oh, it did. Okay. So this is saying that, I don't know why it won't jump to that line number, but it's saying that we have this list in our list of exported things that we didn't define, which is true, because we replaced it with tie categorized goal. Okay. So codomain test failed for built-in goal. What that means is that if we jump to this line number, we returned something which doesn't match this pattern, which is strange. And the thing we returned was built-in goal. Oh, that's because I called it goal classification, not goal categorization. So I guess I'll rename it because I think I use the other name everywhere else. Yes, that would probably help. You like the Jeopardy music. Okay. Still have another failure. Codomain test failed for built-in goal. Let's just check why. So we called categorize goal. Oh, because it's declared to return a Boolean. That's not correct. Okay. Okay, now we're getting the same failure we got before. And we can also test all the things. And we won't have time to do the fix, which is too bad. But I think it's actually relatively straightforward. Essentially, we're gonna, so let's see, refactor is predicate and friends to categorize goal. Instead of a bunch of functions that return Boolean, we now return a goal slash categorization. Looks like there's some kind of bug because this isn't working. So I'll look at those failures later, but I'm sure it's some typos. But the basic fix to this problem is going to be that we have to change user predicate to be like, where's the co-inductive flag? Change user predicate to user predicate, to carry a proof co-inductive along with it, which we can then match out and pass in. And then we have to adjust the various functions that return user predicate to return that. Okay, thanks for attending. And I'll post this video after, and I'll push this branch somewhere. But yeah.
Yeah, thanks.
Bye.
Ciao.
Bye.